Are negative ions good for you? Normally, I'd dismiss such a question out of hand. In fact, that's exactly what I did when a friend brought it up about a month ago. But he was insistent. He said, no, this is for real. There's science behind it. And so I looked into it and I found this. There are literally hundreds of published peer-reviewed scientific studies on the biological effects of ions. It's a body of research that begins about a century ago and continues to the present day. And this is just a fraction of it. Now, these studies aren't just about any old ions, they're about atmospheric ions or air ions. And although the results are not uniform, they all begin with the premise that positive ions make us feel bad and negative ions make us feel good. So in this video, I want to get to the bottom of this. These are Himalayan salt lamps.
With the heat from the light bulb, it releases negative ions into the air. And of course, negative ions are what you breathe in and produces serotonin in the body. And serotonin is like the primary neurotransmitter in your whole body and all living things. And that's what makes you feel good.
Awesome. Can I jump in here for a second? When I first heard all this business about atmospheric ions, my first thought was, why should we expect there to be many ions in the atmosphere at all? I mean, to recap, an ion is just an atom or a molecule that has gained or lost an electron. If it loses an electron, it's a positive ion. If it gains an electron, it becomes a negative ion. But here's the thing. Unlike charges attract. So moving about in the atmosphere, I'd expect the positive and negative ions to find each other, and then boom, they're back to being neutral. However, as it turns out, there are some processes that are constantly generating atmospheric ions. For example, cosmic rays. These are highly energetic particles from across the universe that slam into our atmosphere and transfer their energy to the air, creating ions in the process. Cosmic rays are thought to create around 500 ions per cubic centimeter at ground level. In fact, they're the most significant source of ions generated over the oceans. But here on land, there are other sources of ionization. Things like natural radioactivity. There are these long-lived isotopes of uranium and thorium, and their decay products that can spit out highly energetic particles in the form of alpha, beta, and gamma rays. These ionize the air. They vary widely from place to place, but they can contribute hundreds up to many thousands of ions per cubic centimeter. If you were to recommend one of these to me that has the most negative ions, or which one do you think?
I would just go for which one's hottest.
Yeah?
Because it's the heat from the light bulb that creates the heat, which makes the reaction in the salt.
Got it. Is that?
Wow, this one's great.
Yeah?
This would just be perfect. Here's...
And then you have thunderstorms. Each lightning strike generates copious amounts of ions. Perhaps one of the more surprising sources of negative ions is waterfalls. As water droplets collide with each other or with wetted surfaces with high velocity, the water molecules create this electrified spray with negative ions that can be transferred to the air around it. Depending on your distance from the waterfall, ion levels can reach tens of thousands of ions per cubic centimeter. And the same effect occurs with ocean waves crashing on shore. Hello.
Hi, Derek. How are you?
Good. Can I give you that?
Sure.
So what I want to know is how many negative ions are there coming off that lamp when it's on?
We have a technique involving mass spectrometry that measures negative ions coming off of solids, and so we can give it a try.
Are you an ion expert?
I've been studying ions for 55 years.
Whoa.
And I've written hundreds of papers on all aspects of ions.
So this is my salt lamp. It's meant to give us lots of negative ions. Can you tell me whether it's giving us some negative ions?
We're going to have a look, and the thing we're utilizing here is that the inlet to this mass spectrometer is at atmospheric pressure, and if there's ions there, we'll be able to detect them.
So this is like, is it kind of like an electronic nose or something? for ions.
You could think of it as
the
a
ions.
nose for ion. Yeah,
Okay.
yeah, it sniffs the ions.
Okay. The lamp is next to the ion sampling cone. I mean, it's not on yet, but we see if there's any ions coming from it.
Yeah. So this display here, this is our mass to charge axis here. So how heavy they are in molecular weight, essentially, and if there's ions being formed, we're going to see some signal on this screen.
Maybe like some peaks.
Some peaks, yeah. There we go. Now, does it need to warm up, or?
I think that's the idea.
Yeah.
Now, there are some places that do naturally have lower concentrations of ions, namely the interiors of houses and businesses, because these structures provide some shielding from the cosmic rays and from the natural radioactivity. Plus, if you have metal ducting and air conditioning, well, some of those charged ions will get stuck in the ducts. So typically levels inside homes and businesses can be as low as around 100 or 200 ions per cubic centimeter. Ion concentrations are also typically lower in polluted areas, in big cities or around factories. And that's because the ions actually cling to those pollutants, or the aerosols, and so they don't live as long in the atmosphere. So the assertion that we live in environments with fewer ions than our ancestors is true. If you're thinking that you feel better around waterfalls and oceans and after thunderstorms than you do in polluted cities or around big factories, well, maybe that's the reason why scientists have been studying the effects of negative ions on human health for nearly a century. So let's consider the evidence. In one study, people suffering from seasonal affective disorder were randomly assigned to one of three treatment groups: bright light therapy, high concentrations of negative ions, or low concentrations of negative ions. They found that both bright light therapy and high-density negative ions independently produced antidepressant effects, but not low-density ions. In another study, participants in a high-density negative ion environment had significantly faster reaction times and reported being more energetic than those in an ambient air control. Now, if all this sounds too subjective, EEG experiments showed people exposed to high-density negative ions had a slower alpha wave frequency with higher amplitude. Participants also reported increased relaxation, alertness, and improved working capacity. And opposite results have been found with positive ions. In one study, volunteers were exposed to high concentrations of positive ions for 2 hours. Symptoms of anxiety and excitement significantly increased. During the time of exposure, serum serotonin levels also increased significantly. This has even been taken into real-world work environments. An air ionizer was fitted to the air conditioning unit in an office building and periodically turned on and off over 12 weeks. When the ionizer was pumping out negative ions, workers reported 50% fewer headaches. They also reported increased alertness, perceived atmospheric freshness, and environmental and personal warmth. It's feeling pretty hot. It's been on for an hour.
It feels much warmer, yes.
Yeah. So the question is, can a salt lamp generate negative ions? Let's check for negative ions.
Let's look again. Doesn't look like it.
But, I mean, there's not even like a background.
No, there's not. It's just like it's not even sitting there.
So your conclusion after testing this device is that it's producing no negative ions?
We're certainly not able to detect any negative ions.
The idea for how these salt lamps are meant to create negative ions is that water molecules are meant to land on the surface and liberate chloride ions from the lattice. But ask any chemist worth their salt, and they'll tell you the energy required to do this is way too high, so it just doesn't happen. What I find ironic is that there are crystals which, when heated, will produce ions. It's just that salt doesn't have the right crystal structure to make this work. The gemstone tourmaline does.
Those samples are worth many thousands of dollars. Tourmaline has a structure such that if you heat it and cause it to expand, it will actually develop an electric charge on the faces of the crystal. You have discharges between those faces, break down in air and forming ions, and that charge then can get transferred to any organic molecule that's present in the air. A 5-degree change was enough to generate ions.
I just find this extraordinary that there is a crystal, there is a material that you could heat up and create negative ions. So the reason people wouldn't have tourmaline lamps is because tourmaline's just really expensive. Okay, so we didn't get any ions off of the salt lamp, but I brought something along that I think might give us some ions. This is an Ionic Air Purifier. When this product was first launched, it sold 2 million units. It works by using high voltage to ionize the air and accelerate those ions to produce the light breeze you can feel, without any moving parts.
Okay, I feel a breeze coming out of it.
And that should be going into the nozzle?
Yep. We've got it pointed right at our ion inlet, so that's good. We seem to be seeing some ions at the moment, and we have the ionic breeze right up next to the source. So
These are negative ions.
these are negative ions.
So if you want negative ions, what you need in your house is not a salt lamp, it's an Ionic Air Purifier. Before you rush out to buy one, I should warn you that generating these ions produces an unfortunate byproduct, ozone.
So right now we're measuring about 17 parts per billion, actually, of ozone. So let's put this up to the front and see whether or not we see an increase in the amount of ozone there.
It's up over 80.
So now I think we're actually at the level of a smog alert.
So you're saying that this device is creating air that would be considered smog in a city?
I believe so.
That is kind of ridiculous for something that's meant to purify the air. Can you smell the ozone?
Yeah.
Whoa. Does it trouble you?
Oh, it doesn't bother me. I know it, and I want to either leave the lab or turn it off.
What am I smelling for here?
It should kind of the sweet smell.
Oh yeah.
Does it smell a little sweet?
Yeah.
Yeah. A lot of people like that smell, but if you smell that, it's not good. So perhaps we should shut this off before we asphyxiate ourselves.
So, generating clean negative ions is challenging. But is it even worth the effort? The research is inconsistent. No significant difference. Evidence for beneficial effects of negative ions on mood and performance could not be demonstrated. Of the studies that report significant results, many have methodological problems. In some, participants weren't blinded to the treatment they were receiving. When they were blinded, they may still have known when negative ions were present by the faint smell of ozone. Most of the studies have very small sample sizes. Plus, they surveyed participants on a number of measures, increasing the likelihood that at least one would show a significant difference, just due to random chance. Ion levels were typically measured at the source, and the distance to subjects was not tightly controlled, nor were the other components of the air. So there's no guarantee the participants were even receiving the expected levels of ions. A meta-analysis from 2013 reviewing all the prior human ion studies concluded there was, quote, no consistent influence of positive or negative air ionization on anxiety, mood, relaxation, sleep, and personal comfort measures. The only link they found was between negative air ionization and lower depression scores, though the authors caution future research is needed to evaluate the biological plausibility of this association. Because fundamentally, the idea that ions have any biological effect is implausible. Consider that in a cubic centimeter of air, there are 10 to the 19 air molecules. So even with tens of thousands of ions, the amount is insignificant, not even 1 part per billion. We're talking parts per million billion. And there's no reason to suspect the extra electrons would do anything anyway. I mean, in your daily life, you are constantly building up charge on your skin and discharging it through little zaps, say when you touch a doorknob.
What do a few more stray electrons extracellular do?
Yeah.
Probably not much.
So if ions do anything, it would likely be indirectly, say by removing pollutants and odors from the air. The ions would cling to the chemicals and then they would, say, get attracted to surfaces or something?
Surfaces and stick to the surface. The chemicals stay on the surface.
So I think ultimately, if you are looking for a way to improve your mental and physical health that is backed by strong scientific evidence, then you should take a walk outside. I mean, you can walk near a waterfall or near the ocean if you like, but the thing that is proven to boost your mood is the exercise. And as an added bonus, you're guaranteed to get some fresh air.